Hello, I'm Ethan. The paper I'm going to talk about is Enhancing Energy Efficiency in Residential Buildings, a comparative analysis of supervised and unsupervised learning techniques. Let's talk about the background first. The study was conducted using Google Colab to implement algorithms in a Python programming environment for 12 residential buildings in European countries like Greece, each building housing 7 persons. A total of 768 data were developed, and each building is a composition of 18 elements. All the buildings have different surface area and dimensions, but have the same volume. The input and output variables were given without normalization. The purpose is an estimation of 2 targets by using 8 variables. Both the heating load and the load for cooling were the desired variables. A categorical target variable denotes 2 classes such as low and high. The research aims to address the challenge related to optimizing energy performance in buildings, particularly focusing on reducing energy consumption to enhance energy efficiency. The study seeks to forecast the energy efficiency of residential buildings by utilizing machine learning algorithms and exploring the impact of energy waste on the environment. The primary objective is to estimate the heating load and cooling load for residential buildings using a dataset of buildings in European countries, emphasizing the importance of energy management and conservation. A total of 9 machine learning algorithms are used in this paper, among which supervised learning includes logistic regression, naive Bayes, decision tree, support vector machine, random forest, data boost, XGBoost, and unsupervised learning includes K-mean clustering, agglomerative clustering. The dataset was obtained from the UCI repository and Synapse and CFR, consisting of 8 input variables related to conditional factors and 2 output variables representing heating load and cooling load. The data was generated for 12 residential buildings in European countries like Athens and Greece, with each building housing 7 persons and comprising 18 elements. The input and output variables were not normalized, and the dataset included information on the surface areas, dimensions, and volumes of the buildings. Is the result. Logistic regression helps find solutions for classification problems. Implementing the logistic regression on the dataset, the achieved area under the receiver operating characteristic curve rate is 97.4%, which shows a high classification achievement. And classification algorithm performed on the dataset include naive Bayes, decision trees, and support vector machines. When data points are classified using these different classification algorithms, they achieve different accuracy scores, as shown in the image to the right. The decision tree algorithm's classification accuracy score of 93% is the highest. The support vector machine algorithm score an accuracy score of 89%. The naive-based algorithm scored a classification accuracy of 91%. The decision tree classifier performs the best in the terms of classification. This paper used silhouette score to evaluate the performance of the clustering algorithm. For the dataset, the agglomerative algorithm's silhouette score is about 69, while the k-mean algorithm's silhouette score is about 57. The agglomerative clustering has performed well in this dataset and has achieved higher accuracy than the k-mean clustering. Their other post is built using 3 different base estimators: the support vector machine, decision tree, and logistic regression. The other post with base estimator as SVN has an accuracy rate of 86.5%. Base estimator and as decision tree is 96.7%, and base estimator as logistic regression is 95.4%. Decision tree as a base estimator in Adapus has a better performance than the SVN and logistic regression in Adapus. For ensemble methods, the accuracy of the random forest prediction while performed on the dataset is 86%. Similarly, the accuracy achieved by the XGBoost algorithm for the dataset is 88%. Among all ensemble methods, Adapus performs best with an accuracy of 94%. The last part is PCA, Principal Component Analysis. By combining the concept of the Principal Component Analysis with the agglomerative clustering algorithm, agglomerative clustering uses the modified data from PCA as its input and scatter plot the data point. Clusters can be differentiated using color codes is shown in the image. There is only a short paragraph in the paper that talks about PCA. It only provides the data that has passed PCA to agglomerative cluster. It does not provide data on how much improvement it has made. However, it is mentioned in a conclusion that PCA is important for understanding data relationships. I think this is probably the thing that they want to do. So the author only mentioned it a little bit, which is, I think it's a bit. This is a link of the paper. My presentation ends here. Thank you.